In this video, we are going to look at domain and range of functions. If you recall from previous video, we can I think you would remember that domain is the set of all first elements of the ordered pairs in the function, and likewise range is the set of all second elements of the ordered pairs in the functions. Now these definitions are quite fancy. Practical and useful definitions are that domain is a set of all values that X takes, and range is set of all values that Y takes. Now it looks these definitions look quite simple, and we'll straight away go to examples and see how we can determine these. So we'll start with simple examples first. First one is we are going to find domain and range using graphs. Using graphs, or when the graphs are given. So determining, this is how I think I should write, determining, so wrong spelling, domain and range from graphs. So graphs are given, and from that you need to determine domain and range, and you will find that this thing is pretty straightforward. So very first function that I have is this, that goes like this, and this is my X and this is my Y. That point is -2, 2. Now I can see that there's an arrow here, which means it is extending all the way up to infinity in this direction. So it goes on and on, but here it stops here on this side. It's just a hollow circle here. That an empty circle here, it means that particular point itself is not on the graph of the function. So domain, we can easily see the domain here. Domain is set of X such that we can see that X values go from here all the way to this side, but this value is not included. So I will say X is greater than -2 and X is a member of R. Now I don't need to write X is a member of R, because if we don't write, then it is implicit that it's understood that X is a real number. But I prefer to do this as a matter of habit. Okay, and range, very straightforward. You can say range consists of Y, such that you can see here that Y is all the values less than this. So this value 2 is not included, because you got that empty circle here which says 2 is not included, but below 2 all the values are included. So Y is less than 2, and again I'll say Y is a real number. That is our example number 1. Pretty straightforward. Let's look at example number 2. So example number 2 is a quadratic function. So a simple quadratic function here like this, and that's the vertex, and the vertex is like this, and I'm putting arrows here, which means that the graph is extending in both the directions here. It's going there and it's going there all the way to infinity. Okay, so it's I think you can straight away write that domain is equals to, because it goes all the way, so it takes all the X values on this side, and from here it takes all the X values on this side. So domain is just the real number line, so X, such that X is real. There's no restriction on the value of X, that value of X in this function, in this graph. And range is, we see that range y is, this is the maximum value of y, which is 3, and then y is always less than 3. So this is y less than equal to 3. Just need to remember that, because that point is the maxima of this quadratic, this parabola, and this is on the graph. So it's y equal to 3 is also included in the graph, and y is a real number, and that's my example number 2. Finding domain and range from graphs is fairly straightforward. I don't think anyone should have a problem in this. Okay, let's look at this. This is a function of degree 3. It's a cubic function, and this point coordinates are 3, minus 3, minus 2. And I just, for more information, I am going to check in coordinates for this point as well. And here it goes all the way. So we can see that x can have values only to the left of this point. So domain is equals to x such that x is less than equals to minus 3. Y equal to, because this is a solid dot here, which means that minus 3 is on the graph. And again I write this, and range y such that all the values of y. So we can see that y can have all the values above minus 2. So that's the lowest value that y can have. And again, it's on the, this point is on the graph, so minus 2 will be included in the range. So, and that is my range for this example number 3. Example number 4, we'll just look at one more example here, and this one here is an asymptote. We'll cover asymptotes in subsequent videos somewhere. So this is my asymptote, and this equation is minus 1, and I have the graph which goes like this, and I have graph which goes like this. So this is y. So you can see that there are two asymptotes. One is a vertical asymptote at x equal to minus 1. Other one is this horizontal asymptote, which is basically just the x-axis. And these considerations go into writing domain and range. So domain here, let's write it here, consists of x such that we can see that all the values of x-axis are valid here, other than this x equal to minus 1. So x cannot have value x equal to minus 1. The function is not defined for this value x equal to minus 1. So that's what we have to write, and then we just say that x is a member of R. And when it comes to range, we have, as we discussed, that there is a, this is asymptote as well, x equal to 0. So x equal to the x-axis basically, and y equal to 0. So y cannot have value 0, and other than that y can have all the values. So finding domain and range from graphs is very easy. Now we are going to find domain and range from the equations, from the function definition itself. Domain and range from function definition. So again, we start with very simple example. So first, function definition is given as this. So here we can see that x has to be positive, because you cannot have a negative number under the square root sign. So that basically gives us our domain. X can be 0 or X has to be positive. So it's X such that X is greater than or equal to 0, and then X is a real number. And range, we'll see that because this is positive, Y will always be greater than or equal to 0. So that also is a range of, that's also is that's the range of this function. Let's look at example B here, and example B gives that f is a function which maps x to x square. Now here we can see that x can have any value because it's just x square. So whatever number you have, whatever value you have, it will get squared. So domain, there is no restriction on domain x such that x is real. And what about range? Because it becomes x square, and x square is always a positive number, no matter what the value of x you put there. When you square it, it becomes positive. So that is our range. Y is greater than or equal to 0. Y is a member of R. Yep, simple enough so far. Look at example number C here. Example number C says that there is a function, f is a function which maps x to 2 minus square root of 4 minus x square. It's a little bit tricky, not much. So when we look at this function, basically we got this thing under square root sign, and this thing can never be negative, which means that x square should always be less than 4 or equal to 4. Yeah, I mean, I can write like this: x square has to be less than equal to 4, which tells you that x has to be within plus and minus 2. So x, I can straight away, I think, write the definition of my domain. Domain is equals to x such that x is greater than or equal to minus 2 and less than or equal to 2, and x is a real number. Okay, once we got this, we need to now look at the range. So we need to find what value this expression can take. So when x equals to minus 2, then x square becomes 4, this thing becomes 0, and you get a value of 2. So I think we can write like this: when x equal to minus 2, what we get, y equals to 2. When x equals to 2, then also y equals to 2, because when you square it, it becomes 4. 2 square, 4 minus 4 becomes 0, and y equals to 2. And when x equals to 0 in between, we only just need to check these values because these are the valid values of x. When x equals to 0, then this becomes 4. The square root of 4 is 2, so 2 minus 2 equals to 0. So that will tell us that our range consists of y such that it is greater than or equal to 0 and less than or equal to 2, and y is R. That's the range for this function. Let's look at one more example. So this example is fx is equals to 2 upon x minus 3. Now you look at this, we can see that x can have all values other than 3. X cannot have 3 because when you have x equal to 3, you're dividing by 0, which you can never do. So domain is equals to x such that x is not equal to 3 and x is a real number. What about range? We can see that y here can have all the values, but it will never have a 0 value. It will never be 0 because no matter what value of x you use here, it can never make y 0. It will get close, become smaller and smaller, but it will never make y 0. So that is your range. Y says that y is not equal to 0 and y is your r. And I think we'll stop now, although I can tell you that many times it would not be so easy to find the range in domain. You will need to sketch the graph of a function. So we'll see those kind of questions later.